Hello and welcome to Sudoku. I've just connected to the Cracking the Cryptic fan server on Discord, and the French constructor Stéphane Bura has posted a new project. I mean, that's a puzzle he's just set, and he puts to the test. He asks testers, well, to test solve his puzzle to, well, for people to mention if they like it, basically. So it's called Murderous Coordinate Sudoku. And here's what it looks like. Well, that's really fancy, all those drawings. It's almost gothic, I'm not sure. Esoteric, actually. So the rule says that apart from the usual Sudoku rules, each gray line linking three digits, X, Y, and Z, read from left to right or top to bottom, indicates that the digits with coordinates X and Y and Z are the same. Well, I think I say Z and Z, well, without thinking. And the number that is on the line is the sum of all three digits. That's really, really a strange rule. It should be fun. Well, at least that's what Stéphane hopes. So I hope so as well. Well, how are we going to address that? Let's start with this 7. This 7 must be 1 plus 2, well, 1 plus 2 plus 4. So we have 1, 2, and 4 in some order, but only 4 can be in a 21 sum. So Kira Sudoku experience or Kakuro experience is precious there. So now those must be 8 and 9. So it's not possible for a 1 to be here because the other two digits must add up to 14, and 14 with two digits requires either an 8 or a 9. So knowing that 8 and 9 are here, 1 is not possible here. So it has to be 1 there, 2 there. So those are 8 and 9 in some order. And for this 15 clue, there must be 6 and 7 in some order. And 3 and 5, how? I think that's 3 and 5 in this order, meaning that 5 can only fit with 6 and 8 to make a sum of 19, and 3 with 7 and 9. So we now have two scenarios. And let's have a look at this coordinate stuff. What is on coordinate 1 and 2? This is this digit. This digit, which is on first row, second column, must be the same as this digit. So this is a 2. I like it already. And what about this? Not sure that's so useful. Oh. What? No. What was I saying? Is something to be done with this? Or this? Well, 1 and 3, I mean, first row, third column is 4. So if this is 1, 3, and 5, then this 4 is on 3, 5, no, is on 3, 5, meaning here. Well, this looks feasible. Oh, let's do some arithmetic here. 19, 18, that's 37. And the sum of all digits on the row is 45. So 27. Those add up to 8 without using the 2. So they are 1, 3, and 4. So 3 is ruled out from this cell. And now all of this is disambiguated. So now we really know that the number on 1 and 3, which is the 4, is on 3 and 5, which is here. Now those digits must be 1 and 3. Which is completed to 12 with a 9 or a 7. And what else? We need another 11 without using 3, 7, or 9. It requires not a digit, so it has to be 5, which is 5 and 6 here. 5 and 6. Let's have a look. 5 and 6. 4, 5. That's an 8. 4, 6. That's a 7. Now 7 can't be both in this and this cell. So if this is a 7, then this has to be a 9 and this has to be a 1. This has to be a 3. 4, 6, 7, 3, 5, and 8. Well, obviously that's so 7. Let's write them the other way. 1, 3. So the right-hand scenario is really, if this is a 6, then this has to be a 7, 9, 1, 3, 5, and 8. And actually, if this is the right-hand scenario with 5 and 8, then both here are plausible, but at least this is a 6. 1, 6, 9, 3, 6, 7. So both digits look possible. Oh, but now we need 2, 7, and 9 in here. 2 won't fit in here. So this is 7 or 9. And to complete to 16, we need 8 or 6, but 8 is not available, so it has to be a 6, then a 9. Those are 3 and 5. 8 and 4. And 2 and 7 on the bottom. So how can we fulfill this 16? This 16 clue, this is 16 sum, 7, 8, that's not possible. Well, actually, this is odd, this is even. To have an even sum, we need an even number. So this must be a 2. We need another 14, and that's not possible. Oh, no, I was completely wrong. To have an even sum, I need to put an odd digit. So that must be a 7, that's a 2. 7 plus 9, 9 is 4 plus 5 only. So this is it. Maybe I should highlight what I've already used on the coordinate side of things. I've already used 1, 2, and 4, and that's about it. Is there something else I can use? Not sure about that. Really not sure. Should I highlight some of the sums? What about this? It will be 2, 3 or 2, 1. So this 9 or this 3 has to go in 7, 2 or 9, 2, meaning here or there. So that's either a 3 here, no, a 9 here or a 3 there. I'm not sure how to use that. Maybe I should pencil mark the positions that are linked. 3 and 7. 3 and 7. That's a 7. Oh, that's a 7 and it goes in 7, 9. So we have a 7 here. Well, 7, 9 I was saying, so that's here. Okay, that's good. 5, 6 and 6, 8. So 5, 6 is here. Let's note it that way. Is the same as 6, 8, which, no, 5, 6 is not here. 5, 6 is here, and 6, 8 is here. So those are close. And let's denote it that way. Wait. Oh yes, 1, 3 and 5 was also used. 1, 2 and 4 was this 2, 1, 3 and 5 was this 4. 2, 7 and 6. 2, 7 is this 4, and 7, 6 is this. So that's a 4. 7, 6, 7, 6, 4 here. 4, 9 and 9, 8. So 4, 9 is here, and it's the same as 9, 8 here. Let's do a little square. This is somewhat tedious. The good thing is that this digit now is neither of those digits, so it has to be 4 or 5. Let's pencil mark this as 4 or 5. There's much less restriction on this digit. It can't be 4, 2, 3 or 8, but well, that's all there is to be said. This 21 sum is not in use right now. Let's have a look at those. 5, 4 and 4, 7. 5, 4 and 4, 7. Let's put a triangle. 5, 4, 4, 7. Then 5, 3 and 3, 6. 5, 3. Oh, and 3, 6 is this. Perhaps I should put letters instead of symbols, of strange symbols. So let's say this was A and this is B. This way. So it has to be 1 or 3. Again. 4, 8 and 8, 1. 8, 1 is here. 4, 8 is here. Let's say C. 4, 8 and 8 and 1. Next, this C has all of those forbidden digits, so it has to be 4, 7, or 9. 3, 8, and 2. 3, 8 is this 2, and it goes in 8, 2, which is here. That's a 2. So this is done. 6, 1, and 1, 9. 1, 9 is a 6, and it goes in 6, 1. This is a 6. Now 7, 2, and 2, 9. 7, 2, and 2, 9. That's a 1. 2, 2, 9. 7, 2, that's a 1. Oh. The given digit. Okay. That's a bit tedious to be honest. But it looks promising, however. Now we need another 15, so they have to be 7 and 8. With this, we know that 7 goes here and 8 goes there. So 6, 8. 6, 8. Really? Oh yes, this 6, 8 goes in 8, 7, which is here. This adds two restrictions. It's neither of those digits, so it has to be 6, 1, or 9. And it's not a 6, so this is 1 or 9. And the fun part of it is that 1 here can't go with the 9 here. So, if I recall correctly, 3 comes with an 8, and 1 can't come with the 9. So 9 goes there. And this is a 1. This is a 3. And let's have a closer look. I think both scenarios are possible. Yes, they do. So now 9 and 2 is here, and it's the same as 2 and 1, which is a 3. So a 3 goes there. 1, 4, and 3, so 1, 4 is a 9. 4 and 1, 4 is a 9, and 4 and 3 is a 9, so it's broken. I have a look at what happened. Someone on the Discord server had the puzzle breaking, which was a... Oh, those are not linked. Okay, that's fine. So it's fortunate that this caused the puzzle to break, because otherwise I would have put a digit that had no business in here. Oh, anyway, with regular Sudoku, these are 1 and 3 in some order. Let's use that. Yes, let's do Sudoku. That's the name of the game, actually. So those are 5 and 9. 2 and 4 in here. So this C can't be a 4. Those are 7, 8, and 9. There's a 7 here, so 8 and 9 here. 7, 8, 9. 5, 6. What have I done? When did I put a 2 under these 2? Was it a long time ago? This is 8, 2, 3, 8. What? When did I put these 2? When did I commit this atrocity? A long time ago, it seems. It was about this 3, 8. So 3, 8 is 2, and goes on 8, 2. Oh, this is no clue. I made the very mistake that I mentioned here. Wow. Okay, that's a test, so you need to get used to the constraint and not do, well, rubbish with them. So, let's start again with what works. 7, 2, and 9 works. So 7, 2 is here, and 2, 9 is here. This is really a 1. Six, 1, and 9. 1 and 9 is 6, and it goes here. So this part was correct. And it goes with 8 and 7, and they are mandatorily in this order. Should I really use such fancy words? So this 619 now has been used. Now, is there anything else? This part with 3 and 9 was really nice. It's a pity I've lost this. Oh, but did I? 6, 8, 6, 8 is still this one, and it still goes on 8, 7 here. So this bit of logic should be okay. And this bit, oh, sorry about that. This bit of logic was that this digit is none of those digits, so it has to be 6, 1, or 9, and it is not a 6, so it's a 1 or a 9, meaning that 1 here can't go with the 9, so this bit was okay. 9 goes here, 1 goes there, 3 goes here. So this 921 still is usable. And it was 9-2 here is the same as 2-1 here. This is a 3. This is 1 or 3. That's right. And I must remember not to use this. This is not a clue. And maybe I should have a look at this. There are two options. The left-hand option is that 2, 5, which is precisely this 5, goes to 5, 6. But 5, 6 is this. When did I encounter 5, 6? Here. And this is not possible. Wow. That's cool. So let's remove this left-hand scenario. So now we have the right-hand scenario. And let's look for consequences. So 2, 6 is the same as 6, 5. And 2, 6 is this 5, and it goes there. 7, 6 is this 4, and it goes to 6, 4. That's here. 8, 5 is here, and it goes to 5, 3. So this digit is the same. The one that was called B. Where was it? Oh, it was this, so it's a 3 actually. That's a 1, that's a 3. Yes, cool. Once again. And I think that's it for the moment. So now let's do this Sudoku part. Here we need 2, 4, 5, and 9. With this 5 and this 2, these are 2, 4, 9, 4, 5, and 9. So now we know that 5 must be here, so this is 4 or 9. There has to be an 8 in there, and those must be 2, 5, and 6. Oh, and by Sudoku there's a 3 here. And soon we'll have a look at this A digit. Maybe I have a look at it right now. So this can't be those digits. So 1, 2, 3, 4, 5, 7, 8, 7, 9. So there must be 6 or 8. Okay, so those are 2, 5, and 6. And now it's time to bring the good Sudoku. Well, not quite. There's still some cloning. There's still some cloning happening. Let's just remind where the close. I think I should remove the pencil marks when they are no longer in use. This 3 is not here with this 3. That puts a 3 in here. Now those must be 1, 2, and 9. Nothing to disambiguate. What else? 2, 4, 5, and 8. Well, not seeing anything. There's an 8 in here. In this column, 1, 2, 8, and 9. Oh, that's nice. That's nice with this. 2, 8, or 9. 1, 2, 8, or 9. This is nice because we have here a hidden quadruple. So only 1, 2, 8, and 9 go into those cells, into those 4 cells. So that's the only place they can go in this 3x3 box. So this has to be a 6. And A has to be a 6 here. And now those digits must be 3 and 7. And with this 3, we get this. This 7 rules out 7 from those C clones. Now we have a 2, 4, 9 triple, so those must be 7, 8, and with this 7, that's an 8, that's a 7. And this 4, 9 pair fixes this 1, 9 clue. That's a 1. Now all those ones may be deleted. And what next? 2, 9, and 6. 9 doesn't go here, so this is 2 or 6, 2, 6, or 9. We still need a 1 in this column, but it's not here, so it has to go down there. 2 or 9 here, because of this 8. Now we have this triple, and this is the same as this. Those digits must be 5, 7 and 8, well, with the digits that are already there, it's straightforward. Not a 5 here, not a 2 here, so this is 6 or 9. Well, those are still not resolved. We need an 8, it's not here, so it's here. Two, 4, and 7 in here. Oh, yes, 7 and 8 are not here, so they must be there. 7, 8. This is not a 2, that's 5 or 6. 2 or 9. What is left to be done? In a normal Sudoku, uniqueness would say that this is a 6, but we are not allowed to use uniqueness when we are test solving, and this is not normal Sudoku, by the way. Oh, 8 is ruled out from this cell, so now this is an 8. Those must be 2, 4, and 5. Now we have all candidates. Oh, but on this row, 2 can only be in this cell. So this is a 2. That's not a 2. Now, what next? Let's remove those small circles. Only those digits need some sorting out. So what about those? Is this some short chain of elimination, or is there something more fancy? Oh yes, there is something more fancy. There's a skyscraper here on 2s, meaning that, well, one of those 2s is wrong, so that this one or this one is right. So any 2 that is seen by both those 2s must be wrong, and this one must be wrong. Well, that's fancy, but is this enough? And that's another matter. It does not look to be enough. Is there a chain? Not sure about this. 4, 9, 2, 9, 2, 9, 9, 6, 6, 5, 5, 4. No, doesn't work. Should I brute force something? Oh, I think this. Oh, those are linked. No, and those. No, those are identical. No, but I was just thinking. This one sees both of those. What if it's a 9? If it's a 9. By Sudoku, this is a 9, but this can't be a 9. So 9 is ruled out, and 9 goes in this C. And the rest should follow, and in this C as well. So this is a 4, that's a 5, this is a, well, let's just see. So this square must be a 4, and let's check that everything goes well from this. 6, 2, 9, 2 and 4. That's a 2, that's a 9. This is a 5. This is a 6, that's a 2, that's a 5, and it all works well. Okay, so to sum it up, I messed up at some point, but that's me. And I got a little carried away with all those lines and those non-existing lines. Okay, the coordinate stuff seemed to be a bit tedious in the beginning, but once I got the hold on it, it was kind of fun. And once the somewhat tedious part was over, the rest of the Sudoku part was really nice. The disambiguating between those digits was somewhat tricky, and I had the vision of seeing the right elimination quite fast, I must say, but perhaps I was lucky, but it wasn't plain bifurcation. It seemed right to have a look at this digit, and 9 seemed to be a good candidate. Maybe 4 would have worked the same way, I'm not sure. Anyway, that was a good puzzle, a really good one. And as always, Stéphane has some very good imagination. Thanks for watching this video, and see you later on Sudoku.